So planar mapping is used primarily for larger, flatter, or smaller, but flatter areas, as well as just trying to combine everything into one bunch of UVs that's connected that you can then dissect later. So if I select this object and I go in and turn on my checker map, we can see all kinds of distortion. Now, I can either planar map an entire object, or if I go to, I'm inside of my UV toolkit, and I can go to planar. You'll notice all these are also under your UV menus inside of here. And remember, whenever you have a little box, that means you can go into the options. But rather than me dig through here and go and say which axis I want to project on, I can actually go inside of here, and if I put my cursor over, you see that the left mouse button projects with the current settings, middle mouse on the Y, right mouse on the Z, and shift left mouse will pull up my actual options. The way I usually like to do this is if I just go and let's say we reset this, I just do a couple of things different. The only real thing is I make sure it's set to the x-axis so that when I left mouse click, it'll be the x-axis. And that way the middle mouse is Y and then the right mouse is Z. And then if I want camera based, I just click this button. But I like to say keep image and width and height ratio, and that makes sure that it stays a rectangle if it's a rectangular area. So now I can just say project, and you see it automatically does that. And you see it's projecting on the X. Whereas if so left mouse, middle mouse is on the Y, you see it's projecting straight down. And then right mouse button projects on the Z. Now I can choose faces and areas and do that, or I can just do the whole object. So I can select the faces I want and project that down, or I can just select area by area. But this is how you would actually start. Let's do middle mouse, and that gives me a nice one for the top. But everywhere that it's red, you can see it's either means that the UVs are overlapping or they're reversed, so that the projection and the text would be backwards. And that's what that coloration is showing up as, where you have blue and red, so that when you're actually seeing those different shades, and we can turn those on. Here's the wireframe where I don't see that at all. Here's the shaded view where I could see what's actually reversed. Now ideally you don't want any of this red. There's a couple of instances where it doesn't matter, but we'll talk about those later. But for right now, this is just the setup here. And then I'd have to break them apart into their own separate UV shells. And that's what basically projection mapping is doing. It's taking whatever texture or grid you might have and projecting it on the object based off of an axis. So in other words, I could do a projection. I wouldn't want to necessarily do a planar projection for every single angle, because that's just going to give me a whole lot of extra work that I don't want and don't need, and it's going to waste my time. But I can also look at these as primitive objects, and even though these are flat planes making the legs, you could, and we'll talk about that later, you could just grab components of the legs and do a cylindrical map and open that up. But when we're looking at projection maps, so once again, I could just do, oh, you know what? Let's say we grab the whole object and then we do a left, or basically in this case, an X projection. But the top is on the Y. That's where the flat is facing. So I could even do right click, go into face mode and select the top. And then we'll hit shift period to grow that selection. And since there's a bevel there, I'm going to grow the selection a little bit further. Watch this. Boom. So I've got the top and the sides. And then I could just do a planar map on the Y. And you'll notice that now it has this darker line because what I did was I made the selection all the way up into that point, and now that is its own separate UV shell. There's distortion here, and we're going to fix that. But for right now, I just wanted to describe what planar mapping is.